Right guys, in this video we're going to have a look at sequences and how we work out the nth term rule for each sequence. First thing to say is we have to be aware of this first aspect here. So 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5. Okay, this is basically how we work out the 6 times table. I want to know how we get the nth term rule for the 6 times table. Hopefully you can quite easily see that if I'm doing 6 times 1, 6 times 2, 6 times 3, a general rule would literally be 6 times n, where n is just whatever number in that times table I want. Okay, so 6 times n would give me anything in the 6 times table, and I can simplify that to be 6n. So 6 times n is just 6n. Exactly the same thing here. If I want the 5 times table, 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, and so on and so forth, the general way, or the nth term rule, would just be 5 times n, which I can simplify to be 5n. Okay, so whatever the times table is, that's how you do it. If it's the 3 times table, it's 3n. If it's the 4 times table, it's 4n. If it's the minus 3 times table, it's minus 3n, and so on and so forth. Okay, that's going to be important for when we do this next bit here. So, I'm just going to get my red pen. When looking at different sequences, if we start off with this one here, we have a look at what it goes up in. So, this first one up here, go from minus 1 to 5. So we're going up 6 each time. Okay, add 6 each time. So we ask ourselves, what other sequence goes up in 6s? Well, the 6 times table. So what we do is we write the 6 times table underneath. So 6, 12, 18, and so on if you want to. Okay, and as we said over here, the nth term rule for the 6 times table is 6n. So what we do now is have a look. How do I go from the 6 times table back to my original sequence? Okay, so how do I go from 6 to minus 1? Well, I take away 7. Exactly the same thing here. 12 take away 7 gets to 5. 18 take away 7 gets to 11, and so on and so forth. So the nth term rule would be 6n, because it's the 6 times table, and then take away 7. Okay, and that's how you work out the nth term rule. We'll do a few more examples. So let's have a look at this one here. Again, what's it going up in? Well, we're adding 5 to that one, and again we're adding 5, and again. So this one's going up in 5s. So what other sequence goes up in 5s? Well, it's the 5 times table. So 5, 10, 15, and so on and so forth. And again, just like I said over here, the nth term rule for the 5 times table is 5n. So how do I go from the 5 times table to my original sequence? Well, 5 to get to 8, we add 3, and exactly the same thing here. 10 add 3 is 13, 15 add 3 is 18, and so on and so forth. So the nth term rule for this particular sequence would be 5n for the 5 times table, and then add 3. I'll come to this one in a second. I'll jump to this one. So this one here, this one is decreasing. So what's happening here? Well, we're taking away 2 each time. As you can see, we're taking away 2 each time. So what sequence goes down in 2s? Well, the minus 2 times table, which is exactly the same as the 2 times table, except it's negative. So minus 2, minus 4, minus 6, minus 8. And what is the nth term rule for the minus 2 times table? Well, as you probably guessed, it's just minus 2n. So how do I go from the minus 2 times table back to my sequence? Well, to go from minus 2 to 10, I add 12. And you can test it on all of them. Minus 4 add 12 is 8, minus 6 add 12 is 6, and so on and so forth. So the nth term rule for this one would be the minus 2 times table, so minus 2n, and add 12. Okay, and that's the nth term rule. I've deliberately left this one because there's a few questions that I want to do that could also be asked on the exam. But first things first, let's work out the nth term rule in exactly the same way we've been doing here. So what's this going up in? Well, we add 3, we add 3, we add 3, so we're going up in 3s. What other times table goes up in 3s? Well, that's the 3 times table. So 3, 6, 9, 12, and so on and so forth. What's the nth term rule for the 3 times table? Hopefully this is getting really easy now. It's just going to be 3n. How do I go from the 3 times table to my sequence? Well, 3 to 2, I take away 1. Just check it. 6 take away 1, 9 take away 1, 12 take away 1. Yep, it works. So the nth term rule would be 3n take away 1. And I'm going to write that down here as well. The nth term is 3n, so the 3 times table, take away 1. Why is it useful? Well, just like for this question here, when it says, what is the 100th term? All you do is you substitute 100 into n. So I'll do 3 times by 100, because I want the 100th term, so the n is replaced by the 100, and then I take away 1. Well, remember, do multiplication first, so 3 times 100 is your 300, take away 1, 299. Okay, and that works for anything, the 50th term, the 1000th term, whatever, just substitute those numbers in for your n, and you can get that term straight away. Another question that might get asked is a particular number in the sequence? So for example, this one here is 149 in the sequence. Now if you've worked out the nth term rule, which we have, this is quite easy. So all we do is we take the nth term rule, which we said was 3n minus 1, and we say, right, we set that equal to 149. Now, if, when we solve this, n is a whole number, then yes, it's definitely in the sequence. And if it isn't, then it's not in the sequence. So let's solve this. Different ways you can solve it. I'm going to use the flowchart. So I start off with n. I times by 3, because it's 3n. I take away 1, and I'm left with 149. I go backwards. 149 plus 1 divided by 3, and I get back to n. So 149 plus 1 is 150, divided by 3 is 50. So because n is a nice whole number, yes, it's definitely in our sequence. 149 is definitely in the sequence because it's the 50th term. And just to do another one, just to prove the other way around, so is 99 in the sequence? Initially it looks like it might be, because 3 times table, 99, yep, looking good, but always check it. So 3n minus 1 equals 99, and again solve it, bit of flowchart. N times 3, take away 1 is 99, go backwards, 99 plus 1 divided by 3, and we get back to n. So 99 plus 1 is 100, divided by 3, no, it's going to be 33.333 recurring, etc., etc. Okay, so no, this one is not in the sequence because n is not a whole number. Okay, and that's how you can prove if a number is in a sequence or not. Hopefully that helps, guys. Cheers.